this is an iHeart podcast. Guaranteed human.
Brought to you by the reinvented 2012 Camry. It's ready. Are you? Welcome to Stuff You Should Know from HowStuffWorks.com.
Hey, and welcome to the podcast. This is Josh Clark. There's Charles W. Chuck Bryant. That makes this Stuff You Should Know.
Two things, Josh.
What?
I got the cheek flap in just under the wire on that one.
Have you done that every time lately? We've been so harried and frazzled in, Pittsburgh.
I might have forgotten some.
We may have forgotten. That explains a lot.
Second thing is we recorded some little promos a few minutes ago, and you called me Chad.
I did. Hey, Chad.
That was a little weird.
Yeah, say hey to Chad.
Yeah, hey, Chad. We do have a colleague and close friend named Chad, so that explains it, but that would have been really weird if you had just called me something
It was
else.
weird. It came out and landed on the table and just laid there like a dead fish in the throes of the end of its life.
I'm going to start calling you Jock.
Okay.
I like guys named Jock.
Have you ever met a guy named Jock?
No, but there's been like movie
Jacques or Jock?
There's been movie characters named Jock.
Yeah. But they're always like the bully at the ski instructor school or something like that, Yeah. They're the guy who gets their comeuppance. I don't get comeuppance. I mean, I get comeuppance like every day, but you shouldn't root for it, I guess is what I'm saying. I don't think I deserve that.
Okay, Jock.
So, Chuck.
Yes.
Do you remember in the Doomsday Scenario episode, what was it? Terror Management.
Yes.
Which had nothing to do with terrorism.
Right.
If you've been putting off listening to that episode because you think it has to do with terrorism,
Nothing.
go back and listen to it. You will be pleasantly surprised.
Agreed.
It was pretty good.
Agreed.
We mentioned that, I don't know if we mentioned or not, but in a report that we cited, one of the things that these people suggested we needed to do, right, to save the planet, was to get busy learning how to mine asteroids.
Oh, yeah.
And I remember reading that, and I was like, whoa, that's a good idea.
Sure.
That sounds awesome.
Pricey.
It is pricey. And I looked a little more into it. Turns out we had an article on the site written by the esteemed Kevin Bonsor.
Yeah, the Bonster.
It's interesting. It is pricey, and there's a lot of holes in any plan that's given right now. But it depends on what you want to do with this stuff, right?
Right.
The asteroids are, well, there's a huge belt. You want to talk about asteroids first in general, and then we can talk about mining?
Sure, Josh. An asteroid belt, well, actually, there's more than one asteroid belt, but there's one main asteroid belt.
It's not that far away.
Nope. It's between,
It's called the main asteroid belt. You weren't just citing it as such.
That's right. And it is between
Mars and Jupiter.
Mars and Jupiter. Thank you.
I'm sorry for talking over you.
That's okay. And there's a lot of theories on how the Earth and the solar system was formed. Mm-hmm. Depends on who you ask. Mm-hmm. One of the more popular theories is the nebular theory. Mm-hmm. And within this theory...
and this is the solar system, not the universe, so just stop emailing right now. Go ahead, Chuck.
Did I say universe?
No.
Okay. Under the nebular theory, Josh,
yes,
astronomers and physicists think that the universe was... the solar system. We're going to get in trouble.
No, we're not, Chuck. Chuck, you're talking about the solar system, and you know it.
The solar system was a big, shapeless cloud of gas and ice, dust, and then something set things in motion.
Probably an explosion is what they think. Maybe a star exploded.
Hypothetical.
Right, and literally set things in motion, right?
Yes.
Into a circular motion, a rotation.
Yes, a tight rotation that spun faster and faster and faster and then started collecting this dust flying around.
Right.
And started forming things. Originally, planetesimals.
That is a great word.
And then more matter's flying around, colliding, and then the planetesimals get caught up on this in a process called, how do you pronounce that, accretion? Accretion. And then they eventually catch more dust and gas and form protoplanets.
Right.
And then eventually they formed the planets that we all think are super groovy today.
So like planetesimals are toddlers, protoplanets are adolescents.
Or tweens.
And then you've got planets.
Yes.
Right? And now we kind of diverge. Like everybody agrees, generally, who buys into the nebular theory, that all that what you just said is correct.
Yes.
But now we reach a divergence, right?
Yes.
So there's the main asteroid belt that's between Jupiter and Mars is far enough away from the sun. There's a big enough distance between Jupiter and Mars with this asteroid belt in between that some people think that that asteroid belt got there because there was a protoplanet there at one time.
Yeah.
That was bombarded, maybe hit by something else, some other space junk.
Like a comet.
Maybe just shot by some other civilization eons ago, right?
Yeah, they think
and
it
it
was a
exploded.
comet. Yeah.
And that these bits and pieces of this it entered into its own rotation around the sun.
Yeah.
And was attracted by Jupiter's gravity, because Jupiter's so big that it influences the movement of this asteroid belt.
Yes.
Basically keeps it in line.
Yes.
So that's one theory for how the asteroid belt got there. There was a protoplanet.
It's not bad, but
No.
the other theory is a little more widely accepted, which is that the asteroid belt is nothing more than a collection of that original debris that never formed
Right.
into a planetesimal and then a protoplanet and then eventually a planet.
Right.
And Jupiter and Mars are 555 million kilometers apart,
Yeah.
which is a great distance. So that's why they thought originally, your first theory, or not yours, but their first theory was, there probably should have been another planet in there
Right.
that got broken up. But the other theory says that no, it never formed. Maybe because of Jupiter.
Again, probably because of Jupiter's mass.
Jupiter's just wrecking everything.
Yeah.
So what we ended up with was a main asteroid belt.
And there's tens of thousands of asteroids in this belt, the main belt.
Yes.
And most of them are about the size of a pebble.
Yeah,
by far the vast majority.
I did not know that.
And then there's just a handful, and we're talking like a handful in galactic terms. So, thousands that are big, and then bigger and big-est. And the biggest one is still not that big, Ceres, C-E-R-E-S, right?
Yeah.
Has a diameter of about 1,000 kilometers. And if apparently astronomers have figured out that if you put all of the mass, all of these pieces together, every asteroid in the main asteroid belt,
Yeah.
if you could put it into a planet or a protoplanet, you would still only have a planet about half the size of the moon.
Yeah,
or about 1,000th
Yeah.
the mass of the Earth. So it wouldn't be very big if it were a
Not very
planet
big.
that had broken up.
But there's a lot of them flying around, Josh.
Yeah.
And the odds of, let's just say you had a starship
Okay.
and you wanted to navigate this asteroid field. The odds of successfully doing so are?
It depends on who you ask. If you were to ask somebody like C-3PO,
Yeah.
you'd have one in like a 6,300 and change chance, maybe?
No.
One in a 5,300.
No.
One in a 7,300.
3720 to 1. 3,721. The odds are very slim if you listen to a robot named C-3PO.
Right. But that wasn't in our galaxy. It was in another galaxy far, far away.
And maybe I should have said droid instead of robot before the listener mail tumbles in.
Yeah.
Or perhaps they're the same. I'm just covering my base.
So, Chuck, size is not the only differentiator of asteroids in the main asteroid belt, right?
Right.
They're also more generally classified by the composition of their makeup.
Yeah.
And if you look at most asteroids, they look like chunks of the moon, just kind of dull and gray, and
Sure.
they might have like a pock mark or something like that.
Right.
But not all of them are exactly alike. They're made up of generally 3 different types of stuff.
Right, Josh. That is the name of our show, so that's appropriate.
Yeah.
We have the C-type, the S-type, and the M-type. M is in Millennium Falcon.
I don't think that's right.
The C-type is about 75% of the known asteroids are of C-type. And they are sort of like the sun in composition, but without the hydrogen and helium and some other volatile compounds.
Right. So they're not going to start burning.
Right. Then you got the S-type. It only accounts for about 17%. And they have nickel, iron, and magnesium.
Right.
And then you got the M-type for Millennium Falcon. And that's the smallest number of asteroids are the M-type. And they have nickel and iron inside them.
Right. And the C-type, where most of them are in the outer ring, the outside of the belt.
Right.
The M-type's in the middle, which makes sense.
Mm-hmm.
And then the silicaceous, the S-type, is the...
Is that what that stands for?
Yeah, silicaceous, like silicon.
Uh-huh.
Carbonaceous, carbon.
And Millennium Falcon.
M-type is metallic.
Ah.
Now, the M-type is the kind that we're probably going to be most interested in harvesting, right?
Yeah, well, we should talk about why do we want to harvest asteroids? For your average Joe out there and Jane, they might say, what's the big deal? We got all that stuff here on Earth.
Well, the point is if it's, well, there's two ways of thinking, right?
Yeah.
One is that we could go to these asteroids, mine all this stuff, because there are precious metals found on there. Platinum, which is very expensive.
Gold. Potentially.
Iron ore, which can be turned into steel, and brought back to Earth and sold, right? So if you happen to be some sort of investor, maybe one who's into space flight or space exploration.
Like Richard Branson, let's say.
Sure. You might be interested in setting up a space mining operation. Yeah. Go get a bunch of platinum. Nobody owns an asteroid. If you, as far as I understand it, if you can make it to that asteroid, you can mine it. It's yours.
Is that the slogan?
That's, I just coined that.
If you can make it, you can mine it.
Right. So you go get a bunch of platinum. You don't have to worry about negotiating with some, junta in a developing country for mineral rights or anything like that.
Yeah.
You just go to an asteroid and get the stuff and bring it back. Right?
And there people are thinking about this. Large corporations are, have plans in motion.
They have ideas.
Ideas?
Ideas.
Okay.
The other and much more reasonable reason to mine an asteroid is to supply a space colony.
Yeah.
Because then that way you don't have to ferry supplies out to space all the time, which a colony is going to need a lot of supplies, and they're going to need them pretty much constantly. That's really inefficient. That's really expensive. They actually think, a lot of smart people actually think that it will be cheaper to set up an asteroid mining operation to basically mine ore to be turned into steel for structures and spacecraft and all that stuff.
Yeah.
And there's some pretty clever ideas floating around. The bringing them back to Earth idea is largely poo-pooed.
Is it?
It is, because, there's so much metal, precious, rare, otherwise, here on Earth that we haven't tapped, and then we won't tap until the price of them is enough to really go to the trouble of getting these, because they're harder to get.
Right, but we are running out of some of that stuff.
But we're running out of the easy-to-get stuff.
Right. Okay,
That's the point, right? So if you take into account that there's a bunch of it there, it's just going to be more expensive.
Right.
It will still be less expensive to mine the hard-to-get expensive stuff here on Earth than to go there and back, right?
Yes, true.
That's one thing. The other reason that selling it on Earth is probably not as good of an idea is you hear numbers bandied about where, like, an asteroid is worth $20 trillion, right?
Yeah, do you want me to read the stat real quick?
Sure.
According to John S. Lewis, who is the author and sounds like supporter of asteroid mining, he wrote a book called Mining the Sky. Mm-hmm. He says there are perhaps 1 million asteroids the size of 1 kilometer in diameter, which would have a mass of about 2 billion tons. And he projects that one of these asteroids could contain, or he says would contain, 30 million tons of nickel, mill and a half of metal cobalt, 7,500 tons of platinum, and the platinum alone would be worth more than $150 billion.
Right, and a NASA report valued the...
NASA
valued all of the minerals and ore found in these asteroids, in the main asteroid belt, at worth about $100 billion per each of the 6 billion people on Earth.
Yeah, it's funny. When I read that, I was like, well, why did they write it like that? Yeah. And then I multiplied it out, and it was some ridiculous 10 to the 26, and I was like, oh, that's why.
That's a lot of money.
Yeah.
But the problem is that none of these outrageous and very attractive numbers take into account things like actually mining them, transporting this stuff back,
sure.
and possibly most importantly, the effect that flooding the platinum market with 150 billion tons of platinum would totally drop the bottom out of it.
Well, that would suck.
It would, because you went to all that trouble and now you're shooting yourself in the foot.
And they're like, hey, guess what? Platinum's not worth anything anymore because we have so much of it.
But likely anybody who could finance and undertake a asteroid mining operation would probably set up some sort of cartel like De Beers and sit on this stuff and slowly dole it out.
Right, or do the math ahead of time. They wouldn't just jump into it willy-nilly.
Right. But using these things for space colonies is a pretty reasonable idea, and there's a lot of people who are behind this.
Yeah, and we should point out too that one of the ways that they find out, because they're not landing on asteroids and drilling into them now. One of the ways they find out what potentially is inside these asteroids is using something called telescopic spectroscopy. Mm-hmm. I thought I was going to say it. I thought I was going to nail it.
It sounds like it sounds like a painful procedure, doesn't it?
Yeah, it does. What they do is they bounce light off of it, and they analyze that reflected light from the asteroid's surface, and that, through the powers of magic, they can tell what might be inside, like magnesium, water, oxygen, even.
Right.
And that's important, because water can't have a space colony without water. Water's key to anything that we want to do.
Yes, it is.
Pretty much.
Yeah.
And you can separate the hydrogen and the oxygen and potentially use that as rocket fuel.
Right.
So water's very valuable on many levels.
And this guy who created the book Mining in the Sky, what's his name? John S. Lewis?
Yeah, Mining the Sky.
He's what'd I say?
Mining in the Sky. Sounds a little more fanciful.
He has a pretty good idea of how at optimum productivity an asteroid could be harvested, right?
Oh, yeah.
Well, yeah, I mean, like, this is kind of what would it look like? Like, in this article, I get the impression that it's largely based on Lewis's conception of what it should look like, right? And one of the ideas that's bandied about is to use robots, right?
Makes sense.
It does.
You don't have to feed robots. You don't have to water robots. You don't have to pay robots a salary, which, makes everything a little bit cheaper.
Yes.
Although it's expensive to build one.
If you can get self-replicating robots, if you can create them, and you're not afraid of singularity, then you're all the better. You just launch a few into space and be like, start reproducing, and then get to work.
Wasn't Alien a mine? The original crew for the Alien, wasn't that like
I think so.
Were they a mining operation?
I believe so, now that you mention it. Chuck, another great idea would be solar-powered equipment.
Sure.
Because think about it, the solar radiation in outer space is not being subjected to the Earth's atmosphere, the deleterious effects of the Earth's atmosphere. So you're getting a lot more cosmic radiation.
Yes.
Which will power these things a lot more efficiently, day or night. It is the one.
Yeah.
Yeah.
You should have light equipment.
Yeah.
Even though it's pretty much a zero gravity situation.
Yeah.
You still got to get it out there, and just lighter is better and more efficient.
Well, you just brought up a humdinger of a point, right?
Gravity.
Yeah. That's a big one. Then there's two things. There's a lack of gravity on these asteroids, and these asteroids rotate. They move, and sometimes they move pretty fast compared to their size.
Right.
Some asteroids rotate as often as once an hour. Some take 2 days, depending on their size. But if you're on an asteroid that's going upside down every hour, right?
It's no good.
No. You can fall off.
Right. Yeah.
And then if you factor in weightlessness, then you have even greater problems, because let's say you undertake a strip mining operation. When you loosen that ore, it's just going to float right off. You're basically breaking up these pieces that form these planetesimals in other cases, and then protoplanets. You're breaking that stuff up. Mm-hmm. And some of the asteroids it's not just like a chunk of rock. Some asteroids are less dense than others. There's a pretty sizable asteroid out there, I can't remember which one it is, that's thought to have about the density of water.
Right.
But it's solid material. It's just not packed together.
Yeah.
So the weightlessness, rotation, and possible low density of some of these asteroids is going to make this a little harder than you would think. But
they got some ideas.
They do have some ideas, especially to take into consideration weightlessness, right?
Yeah, well, one thing they, and this all sounds very rudimentary, but it makes sense. They thought about using a big canopy to collect this stuff as it flies off.
Right.
They have considered the idea of using rocket boosters to keep the asteroid from spinning and, level it out. I saw one idea they had was to use magnets called rake magnets. So they would literally just sort of in the shape of a rake, a giant magnet that would comb the asteroid.
That's very smart.
And whatever loose mineral or metals were on top would stick to the magnet.
That would suck to lose the rake magnet into space, though. It just floats off, and you're like, man, we lost another rake magnet.
And it was $20 billion. Plus, the other point, too, with gravity is what zero gravity taketh away, she also giveth. Because it makes everything much lighter and easier to, Jerry, like that. I made no gravity a woman, I guess. Everything's lighter, so, you won't have to have, like, the massive crane to lift the equipment because it's zero gravity. Or almost zero gravity, right?
Yes, and ferrying back and forth between the asteroid belt and, say, the moon, let's say we put a colony on the moon, is going to take less fuel.
Yeah.
We use up a substantial amount of fuel getting into outer space. Once we're in outer space, we use way less.
Sure. And then also, the other cool thing is once you're set up there, you can mine an asteroid, and then you can take it for all it's worth and just move to the next asteroid.
Yeah.
You don't have to go back and forth and back and forth.
And that, too, raises kind of a point. Like, I know this is a very nascent field in the fact that it's not in existence yet.
Right.
But nobody's talking about what effect this could possibly have if we start basically just mining an asteroid belt.
Like, is there a reason?
Into nothing. Let's say we remove all the iron ore from the main asteroid belt. What happens to, say, the rotation? Do they start flipping out?
Yeah.
There's no talk about even going to the main asteroid belt. Right now they're talking about just getting ones that have kind of wandered away, called near-Earth objects, near-Earth asteroids.
Because a lot closer to the Earth is much better for
and sometimes
a lot of reasons.
They're closer than the moon is.
Yeah.
So it'd really be easy to ferry to the moon, right?
Yeah, we landed on the moon.
But I can't help but wonder if eventually, in a century, we ramp up and are in the main asteroid belt, like really undertaking mining operations. It'll have some sort of horrible effect that no one figured out until it was too late.
Yeah. They'll all start spinning into Earth or something.
Still, though, it's a good idea. It's probably a necessity if we start to colonize space.
Yeah.
But don't let anybody tell you it's an easy idea, right? For example, one last example of how difficult this can be. And I very much recommend people go read Ronald Brake's The Great Space Mining Con, I think is what he called it.
He poo-poos it, right?
He poo-poos it. He poo-poos bringing it back to Earth, and he's got a lot of great examples.
Oh, okay.
He says, using it for space is a good idea. But one of the things he points out is when we go and get ore, right? Say iron ore.
Yeah.
We get them from veins. There's like a vein there, and we can get a bunch at once, right? That's because of Earth's biogeochemical processes that help collect ore, like ore, into the same place. The Earth has a magnetic field.
Right.
All of this stuff contributes taking a bunch of iron ore and putting it together. Asteroids have not been subjected to these processes, right?
So we don't know if it's the same.
It could be completely spread out.
Right.
And there might be a bunch in there using telescopic
spectroscopy.
Okay. We know there's a bunch there, but we don't necessarily know in what kind of density that it occurs.
So you've sunk $100 billion into getting up there to find out that you can't use the same processes that you do on Earth, basically?
I think they probably just do exploratory missions first before sinking in the whole $100 billion.
Maybe so.
We'll find out. We'll find out what Richard Branson's made of in the next year or two, okay?
Yeah. I bet he listens to this.
So we got a bunch on the site. You got anything else?
No. I like these little theoretical musings every now and then.
Oh, I've got one. The Kuiper Belt.
The Mel Kuiper Belt?
So there's another asteroid belt way larger that goes basically out to the frontiers of the solar system.
The edges?
Yeah. And the cool thing about this, the Kuiper Belt, is that it was proposed by Gerard Kuiper in 1951. He's like, there's an asteroid belt out there, and this is probably roughly where it is and how wide it is and how dense it is. And in 1992, it was confirmed by observers who saw that. Yeah, observers, from other planets, I guess.
Oh, and he said, I'm naming it after me.
No, I think he was probably dead. What I'm saying is, he said mathematically, there's an asteroid belt out there. And then 40 years later, they're like, yep, he was right.
Wow.
There's one right there.
Smart.
Pretty cool,
Well, they should have named after him then.
The Kuiper, yeah.
He earned it.
Kuiper Belt. So, that's it.
I think it'll happen. I think we have pillaged the Earth, and we will soon be pillaging the solar system. Likewise.
Okay. If you want to learn more about asteroids, type in that word. It's going to bring up a lot of cool articles. We combine two, how asteroid mining will work and how asteroid belts work. And you can type that into the handy search bar at howstuffworks.com, which brings up listener mail.
Josh, I'm going to call this listener mail from my friend, Ryan.
Is this legal? Yeah, I don't think you can do this.
He sent us a legit email, and I was like, you know what, dude, I'm going to read this. I'm going to plug your band while I do it.
Oh, really?
Yeah, but that's not the reason.
Okay.
Because this is actually pretty cool.
Okay.
Hey, dude. He didn't say hey, everyone, because he was just emailing me.
All right.
While mowing the yard earlier today, I listened to your podcast on how to start your own nation. Great job, as always. I took a particular interest in checking that one out because a couple of years ago, I produced a segment for a TV show, G4 Underground, that never aired on the subject of micronations, and I ended up researching many of the topics you covered on the show. In particular, you talked about the sovereign nation outside of Reno, the Republic of Mollassia. Mm-hmm. I spent an entire day with His Excellency, President Kevin Baugh, in Mollassia, which is actually just a house and a housing addition in a little desert town. And he sent me a picture of him with this dude, and he's dressed like Anwar Sadat.
Yeah, he's got like the sash and everything.
You can recognize it by the Molassian flag flying in the front yard and miniature cannon replica near the front door. I kind of knew going into it that he wasn't very serious about the whole thing, but definitely realized upon arrival that he and the other members of the micronation culture are all just big role-playing nerds. My first clue was his enormous collection of Star Trek memorabilia. I interviewed neighbors who just described him as a nice fella who's just a little eccentric, and I've attached a picture. And maybe I'll put that on Facebook. I'll see if Ryan minds.
Totally.
But Ryan is in a band called Debate Team, and they are awesome. And I have their album, and they're like self-produced, like the truest of indie styles in putting out your own music. And Ryan's like an old friend, and we were PAs together, and now he's like directing stuff, and I'm doing this, and we're all like very proud of each other.
You should leak his album on our Facebook page.
You know, I have posted something before. I'll post it again, but if you want to check out facebook.com/debateteam, it's good, power pop. It's just awesome. I love it. I'm a fan.
What else? What's another example of power pop?
I don't know. I mean, the drummer for his band is also the drummer from OK Go.
Are they power pop?
I would say OK Go is probably power pop.
I could see that. I like them.
But it's not like they're like them. Their Debate Team is their own awesome thing.
Let me change that. I like that one song that they had the first video for with the
which was the
treadmills.
Yeah, but those dudes are like killing it on the music videos.
Yeah, and they're like internet gods and everything.
Yeah,
cool guys.
The Strokes are sort of power poppy.
Yeah. Oh, okay. Yes. Totally.
Some might call them rock and roll.
Rooney.
Yeah, I don't know those guys. Are they good?
They're all right.
They're
pretty good.
All right.
They are. They have some very catchy tunes. All right. Well, if you like power pop, we want to hear all about it.
We do want to hear about it, Josh. Mm-hmm. But we got to let people know about something that we're doing.
Oh, yeah.
We have a next weekend, the 4th of July weekend. Mm-hmm. You're going to be able to listen to us on Sirius XM. Channel, 104?
Channel 10
They're doing a Stuff You Should Know Stuff You Should Know About America weekend, and they're playing like 20 of our podcasts over the course of the weekend on a little pop-up channel. And it's going to be punctuated with some little shorts from our friends at Stuff You Miss in History class,
right?
Deblina and Sarah, who are awesome.
Okay.
And also our live show that we are recording in New York on July 1st with some very special friends from The Onion.
Right.
And potentially other special guests. They're going to play that several times.
Dude, we're basically all over Channel 104 on Sirius XM for like a whole weekend.
Pretty much.
It's going to be pretty awesome.
And you can also listen to Stuff You Should Know now on WFMU 91.1 in the New York metro area.
And 90.1 in the Hudson Valley, right?
That's right. Fridays from 7 to 8 p.m. You can support us on the radio. And they are cutting together some of our archives in a new and exciting ways.
So there you have it.
That's it.
Yeah. If you want to send us an email about what? Power pop?
Yeah.
Yeah. Or if you're a member of a power pop band.
Sure.
Shoot it to stuffpodcast@howstuffworks.com.
Be sure to check out our new video podcast, Stuff from the Future. Join How Stuff Works staff as we explore the most promising and perplexing possibilities of tomorrow. Brought to you by the reinvented 2012 Camry. It's ready. Are you?
This is an iHeart podcast. Guaranteed human.